We will now do the May, June 2022, variant 41 question, number 4. A pendulum consists of a bob, which is a small metal sphere attached to the end of a piece of string. The other end of the string is attached to a fixed point, which is this point here. The bob oscillates with small oscillations about the equilibrium position, which is this point, as shown in figure 4.1. The length L of the pendulum measured from the fixed point to the center of the bob is 1.24 meter. That means that L is 1.24 meter. The acceleration A of the bob changes with its displacement from the equilibrium position as shown in figure 4.2. The graph in figure 4.2 consists of a straight line with a negative gradient passing through the origin, which is this point here. You need to know how to interpret this graph, and also we can get the maximum acceleration Amax and the amplitude XO from the graph. A. State how figure 4.2 shows that the motion of the pendulum is simple harmonic. Figure 4.2 is repeated here. In this question carries 2 marks. In order to get the 2 marks, first you must say that the straight line through the origin, shows that A is proportional, or A is directly proportional to X. A is the acceleration, X is the displacement. Then the second mark comes from the negative gradient shows that A is in the opposite direction to X. That means when your displacement is minus 0.05, your acceleration maximum is 0.40 meter per second square. And then when the amplitude is positive 0.05, the acceleration is minus 0.04. So you can see the A and X are in opposite direction because they have opposite sign. Then B part 1. Use figure 4.2 to determine the angular frequency omega of the oscillation. This question carries 2 marks. The first mark comes from A maximum. AO is the maximum acceleration equals to omega square times XO, which is the maximum displacement amplitude. Or you can put A equals to minus omega square X. Therefore, your omega square is the negative gradient for the straight line. So the gradient for the line is 0.4 divided by 0.05. So omega equals to square root of 0.4 divided by 0.05, which will give you 2.8 radian per second. In part 2, the angular frequency omega is related to the length L of the pendulum by this formula here given to you. So in order to, where K is a constant, in order to find your K, in order to determine the K, we have to square both sides of this equation. So your omega square equals to K divided by L. So from here, K equals to omega square times L. Omega square is calculated already in B part 1. So K equals to 2.8 square times 1.24, since the length for L equals to 1.24 meter. So your K equals to 9.7 meter per second square. As to why the unit is meter per second square, this is the reason. The unit for angular frequency is per second. Omega square is per second square. So the unit for length is meter. Therefore, omega square L is meter per second square, which is the same unit as your acceleration. Then in part C, when the pendulum is oscillating, the length of the string is increased in such a way that the total energy of the oscillation remains constant. In this question, we need to know 3 things. Number 1, the L increases. Number 2, your K is constant as given here. And then your statement says that your total energy is constant also. So suggest and explain the qualitative effect of this change on the amplitude of the oscillation. That means you want to know how the amplitude depends on the length L. In order to score the 2 marks in this question, we can first say that increasing L will cause the omega to decrease. Therefore, the total energy, which is the total kinetic energy, maximum kinetic energy, is half m omega square XO square. Since your ET is constant, the total energy is constant, XO squared is directly proportional to 1 over omega squared. Therefore, when omega go down, decreases, your XO squared will increase. XO will increase. Alternatively, you can also say that the total energy is equal to half mk XO squared divided by L. So when your K and ET are constant, your XO squared divided by L is also therefore a constant since your ET is constant. Therefore, when L increases, your XO squared also increases. Therefore, XO will also increase. It means the amplitude will increase. This is how you score the second mark.